Assalamualaikum and a very good day to everyone. I'm Arissa, Nalia binti Hanif from Management and Science University. First of all, I would like to say thank you to IEEE for this opportunity for letting me to share with everyone about my project that have been implemented. Not to forget, thank you to my supervisor, Dr. Sofa, for his guidance and support throughout to complete this project. As for today, I would like to share with you guys about my project entitled IoT-based design and autonomous bus with QR code as the communication system. What is actually this IoT-based design and autonomous bus with QR code as the communication system? It is actually a bus without a driver to drive or control the movement of the bus. The functionality of this autonomous bus is able to pick up and drop off the passenger at the certain points, and by using the smart system of the QR code as the identifier system to acknowledge the bus of the availability of the passenger at the certain bus station stop. Autonomous bus will be functioned to acknowledge the traffic light signal and the pedestrian walk as it will stop depending on the color of the signal and sensing object to cross the pedestrian walk. This autonomous bus will stop at the bus station depending the QR code that has been scanned. If, for example, if the third station there's no QR code scan, the bus will straight move to the next station that passenger already scanned the QR code. This is a recent research of the driverless vehicle. As for more than 5 decades, road traffic accidents have been a major public health problem, resulting in a large number of injuries and deaths. For the second one, socially, public transport technology can improve the health of the population by increasing the road death and injuries. The third one, in 2016, 521,466 road accidents in Malaysia, 7,152 people were killed. Malaysia is ranked by the World Health Organization, WHO, as the third highest deadly path in the world. This is an accident analysis that have been researched. Most accidents occurred during the midnight to early hour between 12 a.m. to 6 a.m. The human-related risk factors such as fatigue, risky driving and speeding, which are prevalent during the early hours of the day, while more than 50% of accidents occurred after office hours, which are related to using restraint device like a handphone usage while driving. The objective of my project. First, to design a microcontroller as the driving system that able to pick up and drop off the passenger at the certain points. The second one, to implement a QR code as an identifier system that assists the bus to trace the availability of the passenger at the located bus stations. This is the problem statement that autonomous bus could solve. First, reduce expenses on drivers and operation. Second one, that can reduce the amount of truck and bus related crashes occurring due to human error. The third one can reduce the road congestion. The fourth one can reduce the number of traffic risks and can increase the safety of the passenger. This is the advantages of my project. It also can increase the road safety and operating efficiency. The second one, the ability to be transported from a place to place without having a driver. The third one, affordable cost operation and public transport fares. This is the limitation of my project. The limitation of the driverless bus is when a few passengers are not using a smartphone or there's no any internet access, the passenger cannot scan the QR code to send the message to the bus to make a stop. This is the existing autonomous bus that we have in this world. The first one, Oli driverless bus. The second one, Muji Gangcha autonomous shuttle bus. The third one, Baidu's Apollo bus. Analysis between the ordinary transport and independent transport. The first one is the terminology, which is the ordinary human-driven transport is known as a regular transport bus. But the self-sufficient transport is a keen transport that can be detecting nature and require no driver to move. In technology built an autonomous bus versus the regular bus, this self-sufficient transport won't rely on auto components, for example, attractive strips, radio controls, and different sensors out and about. As for the autonomy, the Society of Automotive Engineers, SAE, has 5 fundamental degrees of independence in the vehicle. The first one, the level 0, allows to zero mechanization. Level 1 also needs a little driver support. Level 2, fractional robotization as a replacement of the driver. The last one, level 3 to 5, demonstrate a given self-driving transport. This is the variable that have been used to control the driverless product. The first one is the IR sensor. It's actually works as the human visionary. which is it can be used to detect the obstacle, and also it is a common application in the real-time that people use. The second one, I'm using the Al-Humairi 3D motor driver. This is typical motor driver or motor driver IC, which allow DC motor to drive on either direction. I'm also using the ultrasonic sensor to measure the distance between the bus and the obstacle and the avoidance implemented by the microcontroller. Arduino Uno also works as to drive the DC motor. I'm using the ZAM software. It is to send the message to the Arduino to inform the bus that there's passenger. I'm also using the C motor to move the vehicle. As you can see, this is my flowchart. Before using the bus, the passenger need to scan the QR code first as the first step. There will be two possibilities, which is yes or no. Let's say if it's no, the passenger need to rescan the QR code back. But let's say if it's yes, from the ZAM, it will send the message to the Node MCU, which is the Node MCU will receive the commands from the ZAM. And then the Node MCU will send the message to the Arduino to move the motor driver. The motor driver will move the vehicle to the drop-off point. But let's say on the way to the drop-off point, they detect the object. The driverless bus detect the object. If they detect the object, it will send the message to the Arduino. The Arduino will stop the movement of the bus momentarily. But let's say if there is no object or any obstacles on the road, it will continue move to the drop-off point. From the drop-off point, it will continue to the routing bus where the passenger want to stop. And then the end. This is my block diagram of the project. The Arduino is a microcontroller that I've been using, which is it will receive all the commands from the color sensor, GPS location, ultrasound sensor, and also receive a message from the Node MCU ESP, or also it will send a message to the Node MCU. Node MCU will receive or send the message to the mobile application. From the Arduino also will send the message to the motor driver to move the DC motor. This is my circuit simulation. As you can see, there is a two ultrasonic sensor here from the left for the left side and for the right side of the bus. We also have the Arduino and we also have the motor driver at here. As a project testing, the system flow of the circuit simulation, the first one, the passenger need to scan the QR code first before planning to use the bus. Once the passenger scan the QR code, the design will send a message to the Arduino to inform the bus that there's a passenger. The second one, the Arduino will send a message to the motor driver as to move the DC motor to the location localized of the passenger. The third one, the ultrasonic sensor will be connected to the Arduino to detect any obstacle that measured. The sensor will turn into 1 if there is an obstacle, so it will stop. But if there is no obstacle, it will turn to 0 to continue move. This is a project circuit simulation and 3D design that I've been made. As you can see, I have a 4 bus stop, which is 1, 2, 3, and 4. This is my circuit simulation, which is I'm using the prototype. This is final design of the prototype. This is a side view of the circuit diagram that I've been made. This is the bus track, the QR code, and the smart bus system submission form, which is it will be appear once you scan the QR code. The progress that I've been achieved in my project, as the progress 1, the bus will be stopped on the predetermined route. Progress 2, after the bus receive the input from the database from the apps, so the bus will follow the predetermined route and stop at the bus station where the passenger has scanned to locate their location. The progress 3, the QR code has functioned to determine the location of the passenger, whether they are at the bus stop 1, 2, 3, and 4. Progress 4 also has achieved the mobile apps already set up for the QR code and to determine the pickup or drop of the passenger by the chosen location. Progress 5, successful program to the bus follow the program route to the bus hub once there's no passenger. And it will continue the pickup and drop off system once the passenger scan the QR code, like I've been mentioned at the previous slide. The black box testing that we achieve. The first one, I scan the QR code. Once we scan the QR code using the phone, it will display the bus stop destination form, which is I pass. The second one, the waiting time for the passenger. So after submitting the drop-off destination form, the passenger will receive the estimation bus arrive command, which is I pass. The third one, the test case is the bus stop at the chosen bus stop. Once the passenger scan the QR code and submit the form, the bus will stop at the scanned set destination. Let's say you were at bus stop 2, and then you scan to go to bus stop 4. So the bus will follow the command that you have submitted. So I pass. And the last one, the bus can make a turn at the junction. So I choose the pickup point 1 and drop off at 3, which is, as you can see, my routine at the previous slide. So the bus can make a turn at the junction. So I also pass. This is the final design of the circuit. I've been using the LiPo battery. It is because it's easier for charging. The second one, I'm using the motor driver. It's to determine the direction and speed of the wheel. Ultrasonic sensor is to measure the distance. The Arduino as a microcontroller. The Node MCU ESP8266 runs Wi-Fi to build an IoT products. This is the circuit design where to locate the passenger, and the destination will be input and saved into PHP MyAdmin database. The Node MCU will transmit the data through Arduino through serial communication, where the Arduino will execute predetermined programs based on the information obtained. So this is my conclusion. The objective of this project are unsaid and I also achieved. The design microcontroller system that able to pick up and drop off the passenger at the certain points by using the QR scan code, as the identifier system have been implemented inside this project. I hope this new system could be one of the new innovation in Malaysia in the future to save the world. So after this, I will show you the demonstration video. Thank you, everyone. I hope you enjoy.